Clemens Construction has put this video together to familiarize the people working on our job site about infection control, ICRA 2.0, and to provide an overview of how the ICRA process works. Everyone who works in the construction area plays an important role with respect to the ICRA plan and to patient health. The purpose of ICRA is to safeguard the health of patients and staff that could be adversely affected by construction activities. Consider the following facts. Each year, 100,000 deaths will occur from hospital-acquired infections, or HRIs. Between 5% and 7% of HEIs are construction-related. This means that potentially 7,000 people will die this year from an HRI where the root cause is construction activity. As building professionals, we have a responsibility to do everything possible to reduce this devastating statistic. The dust and debris from construction activities is life-threatening for people with compromised immune systems. The goal of ICRA is to protect the patient population, staff, and visitors who are admitted, working, or visiting the hospital while a construction project is taking place. ICRA has been used by the construction industry for more than 25 years. Recently, ASHE adopted ICRA 2.0 as the best standard of practice. ASHE is the American Society for Healthcare Engineering. ICRA 2.0 is based on a 5-part approach: define activities, identify patient risk, define class of precautions, assess the surrounding area, establish a mitigation plan. In the following slides, we will review these 5 phases. Clemens has put this video together to give you an overview of ICRA 2.0 training. Our goal is to make sure that everyone working on the job site understands how important ICRA is and why we need every person on site to participate in the success of the ICRA plan. If you would like ICRA 2.0 certification, talk to our super. Clemens has certified trainers. We can get you scheduled. The process of building an ICRA is based on defining risk groups and identifying the type of construction. ICRA 2.0 also gets into more detail about the surrounding areas, the process for removing ICRA protection, and other important details. For our purposes today, it's important that you know that an ICRA team collaborated on the best way to implement this ICRA plan, which is specific for this project. Careful planning is key. It is now your personal responsibility to support the plan that the team put together. We need your participation, and we value your input. As a trades professional, if you see a better way of doing something, let us know. We are partners in this process. ICRA 2.0 was developed to build a template for infection prevention that is based on years of experience and data. The ICRA team is focused on the type of work and the processes for construction. This is balanced against the understanding of where the work is being done and who may be affected. The ICRA team has also looked for ways to support common practices for light work and inspections, which occur frequently in the hospital. Evaluating the project from a 360-degree perspective is critically important. The ICRA 2.0 analysis is used to plan the work while considering the people and departments that are above, below, and adjacent to the work area. Patient safety is your responsibility. As a person working in this hospital, you can have a positive or negative effect on patient outcome. Here's a few examples. Keeping ante-room doors shut and opening them in the right sequence will either maintain the airlock or contaminate the corridor. Plugging a rechargeable tool into a red outlet could trip a breaker. Red outlets are on the critical power branch. A tripped breaker could knock out power to life-saving equipment. Making changes to a domestic piping system that results in a dead leg likely introduces bacteria into the potable water. These are examples of how any tradesperson could affect patient outcome and why we need you to be an active participant in patient outcomes. Many of the daily activities you perform as trades professional could impact the patient population. For example, how to enter and leave the work area. Are the doors closed tight and in sequence? Are your clothes or boots dusty? Are you bringing materials in and out on covered carts? The ICRA plan for this project was put together by a team of professionals who are each experts in their own area. The ICRA team included Clemens Construction as the construction manager. We know the details of the construction process. The care staff who understand the patient population. The facilities managers who know the facility and how to keep it operating safely. The infection preventionist who understands pathogens and how they are spread. The first step in the ICRA process is to define the scale of the work activities. How much noise, vibration, and dust will result from the work that is planned? Defining the construction activity into one of four categories is the first step. The categories include Type A, inspection work or non-invasive work; Type B, small-scale, short-duration construction; Type C, large-scale, longer-duration construction projects; Type D, major demolition/construction projects. The second step in the ICRA process is to identify patient risk. The ICRA team from the hospital will evaluate potential risk for patients that result from the construction activities. The risk analysis includes noise, vibration, and dust control. If the construction process is taking place below an operating suite, noise and vibration could have a detrimental impact to a patient during a procedure. If construction activities are taking place in the vicinity of patients who are immune compromised, the presence of dust could have a detrimental impact. These and other factors need to be considered during the planning stage. This matrix is the tool used to evaluate risk for patients. It's divided into four groups: low risk, medium risk, high risk, and highest risk. You might observe that there are no areas within an operating hospital where there is no risk. If a project is in a low-risk area such as a locker room, even in a non-clinical area, there is still a risk because construction activities could introduce dust that is then carried to other parts of the hospital. The bottom line is that working anywhere in a hospital facility requires that we work clean and neat. At the other end of the spectrum, working in the highest risk areas pose immediate and direct risk to patients, even from adjacent areas. An OR suite, for example, is a highest risk area. Think about what the affect could be of unexpected vibration from a chipping gun that transfers through building steel while a surgeon is a critical procedure. Please remember that there are many ways in which construction activities affect patients. Organic growth from mold and similar contaminants must be controlled. Organic growth can occur in the domestic water system if dead legs are left in place or if correct sanitization procedures are not followed. When HVAC systems are compromised, shut down, or otherwise change in operation, resulting temperature and humidity changes can affect air quality. Before work begins to modify an HVAC system, we need to check existing airflows and pressurizations. A plan will put in place to protect any return air grills. Depending on the location and the class, the diffuser and rags may be protected with filter media of an approved MERV class or blanked off. Dust and dirt that result from construction will introduce mold and other pathogens that can be life-threatening to patients. This is why we isolate our construction areas with negative pressure. Defining the class of precautions is the third step of the ICRA process. The ICRA team needs to make reasonable decisions about the type of controls to be put in place based on the work that is planned and the patient's risk. The controls need to be correctly applied to the project. It does not make sense to always default to the highest precautions. The ICRA team will evaluate and propose the best controls for the project. This includes an analysis of airflows, barriers, exhaust air, anti-rooms, material flow, and other factors. The team will craft an approach that keeps patients safe, is economically viable, and allows the work to get done effectively. The matrix shown here guides the type and extent of controls that will be utilized. This matrix considers both the patient risk group from low to highest and the type of project from Type A, survey, to Type D, major construction. This guides the ICRA team to define the types of controls from Class 1 through Class 5, 1 to 5. Each of these 5 classes have specific requirements. For example, the requirement to isolate the work area and maintain negative airflow is not always a requirement. The fourth step of the ICRA process is to assess the surrounding areas. Even when the work is isolated, noise, vibration, and the movement of material can affect areas of the hospital that are nearby. Every part of the hospital is interconnected in some way, and we need to plan for how work in one area affects other areas. Keeping ante-room doors shut and opening them in the right sequence will either maintain the airlock or contaminate the corridor. Plugging a rechargeable tool into a red outlet could trip a breaker in an adjacent area. Making changes to a domestic piping system can introduce bacteria into the potable water. Are your clothes or boots dusty while you walk through the hospital? Are materials being transported through the hospital? Are the wheels clean? Is the cart covered? Temperature and humidity changes can affect air quality. Do we understand the airflow and the pressure relationship when we alter the air balance? This is a checklist that is used in preparing the ICRA 2.0 plan. The systems and controls are evaluated in the columns for areas above, below, lateral, behind, and in front. The project requires a 360-degree evaluation. The team decides what additional factors require controls. For example, noise, vibration, dust control. Then we evaluate what systems could be impacted, including data, mechanical, medical gases, and water. Understanding the work area in 3 dimensions is a key for success. What surrounds the work area and how to control for the effects of construction is an essential part of the planning process. Each of these factors needs to be considered in the evaluation of surrounding areas. The ICRA team will determine how the construction activities affect each adjacent area and how the construction team will control for noise, vibration, dust control, ventilation, pressurization, vertical shafts, elevators, and stairs. Each of these systems needs to be considered in the evaluation of surrounding areas. The ICRA team will determine how the construction activities affect each adjacent area and how the construction team will manage impact on building systems, including data, mechanical, medical gases, and water. The fifth and final step in developing the ICRA is to document the procedures and controls in the mitigation plan. The mitigation plan is a summary of the process and controls that are agreed to by the entire team. It details the controls, specified materials, and the process for the team. It will also document how verification occurs to ensure that the plan is being maintained. Now that we have reviewed the 5 stages of how an ICRA plan is put together, let's review some of the common tools, techniques, and processes that you will see on the job site. Pressure relationships are a key to containing dust. In a negative pressure work area, the airflow always travels from the non-work area into the work area. Therefore, dust from the job site is always being contained and pulled back into the work area. We use HEPA machines to scrub the air and force the construction area into a negative pressure relationship. We then disperse the cleaned air outside into exhaust systems or an area approved by the hospital. In some cases, we rebalance air systems to compensate for systems and equipment that are coming offline as part of the construction project. Tacky mats are placed at the entrance of contained work area based on facility policy. Adhesive mats must be changed routinely and when visibly soiled. If an anteroom has been built, a small HEPA vacuum will be placed in the anteroom so that trades personnel can vac their clothing before leaving the containment area. If negative air is a requirement, Clemens will install a magnehelic gauge near the construction entrance. The magnehelic gauge measures differential pressure between the work zone and non-work zone. The magnehelic gauge proves that the work area is negatively pressurized. When an anteroom is required, it will be constructed large enough for equipment staging, cart cleaning, and the worker. The anteroom must be constructed adjacent to the entrance of the construction work area. Tie-ins and interruptions to domestic water systems can result in contaminations. Plumbing changes and disconnections should avoid dead legs. If you come across dead legs in existing systems, let your foreman or Clemens super know about it. The ICRA permit will be posted on the job site, typically on a job board near the construction entrance. Trash must always be removed on a designated path that was approved on the ICRA plan. Carts need to be covered and wheels need to be clean. Look for the magnehelic gauge near the construction entrance. The magnehelic gauge should always indicate negative air pressure. On some projects, Clemens uses an Omnitech magnehelic, which also records negative pressure reading and will send a text alert if the space becomes neutral or positive. At any time that controls are not followed or environmental test monitoring results are not met, work should be stopped until corrective action is completed. Additionally, interim measures or controls may be required to compensate for failed conditions and until critical controls are reestablished. The process for building and removing ICRA barriers is an important process that requires planning with the facility. Before barriers are removed, they need to be cleaned so that dust on the inside of the barriers does not compromise the facility. Depending on the ICRA plan, it may be a requirement to erect poly barriers for the install and removal of the permanent barriers. When removing barriers, all surfaces need to be cleaned and checked by the hospital IP before removal. HVAC grills and diffusers must be cleaned and wiped down. On behalf of Clemens Construction Company, thank you for your time today. Your participation in the ICRA plan is a key to success. ICRA requires a team approach by every person on the team and every person working on the job site.